Okay, you're looking at number 5. It says use the equation. Now, this equation that you're given is what's called the reduction formula. And someone says, why is it called the reduction formula? They're actually reducing the degree of the cosine in this one over here. Now, I don't think you should memorize this, but I do provide worksheets where we derive these formulas. I mean, there's a large number of reduction formulas, but right now, all they want me to do is to use it, right? Use this reduction formula to rewrite it. That's all they're asking me to do, right? I'm sorry, to evaluate. I want to do that for you. As I'm doing this, I want to emphasize to you, you'd have to be able to identify certain things. So, for example, looking at it, I'm going to say the m in the problem is clearly 3, and the n in the problem is clearly 2. All right? So what I'm going to do, you could write that down if you want, but I think it's probably pretty easy to follow that. So what's going to be? Let's write this over here. And I'll try to be real careful in writing this stuff down. All right, what goes on the bottom is m plus n. Well, m plus n is 3 plus 2, which is 5. And then what do you get over here? Well, you're going to get sine, right, to the m is 3, plus 1, so sine 4, times the cosine. Now, this is going to be n. Well, n is 2, and 2 minus 1 is 1. I'm not going to put the exponent down, by the way. Okay, what's n? N is 2. What's 2 minus 1? 1. What goes on the bottom? Well, we just did, it's 5. Then you get sine. Oh, gee, what's m? M was 3, right? Times cosine of n minus 2. Well, n minus 2 would be 0. So there's no cosines. So I'm going to get this eraser out. I'm not going to put any cosines down. There's no cosines. It says there's 0 dx. Okay, the problem now is that, did the integration get easier? It did. We're looking at this, and now we're looking at this to integrate. And I think I can do it. So they want me to evaluate it, and we're going to go through that step right now. So what are you going to get? Let's write this over here. This equals, I'll put it over here. Whoops. Equals, let's see, sine fourth x times cosine x over 5 plus 1/5. Well, what I'm going to do over here is I'm going to, borrow a sine squared. And a sine squared is going to be 1 minus cosine squared. Times sine x dx. I'm going to do a u substitution. I'm going to say u is cosine x, and du would be minus sine x dx. Well, I think I can do it. And I'm going to put it up here. Sine 4 over 5. And now we're going to take this integration, we're going to change it around a little bit. So I'll put the star here. We still get 1/5. Hopefully it's going to get easier, by the way. And I see 1 minus u squared. That's not an issue for me. And then sine x dx is actually equal to a minus du. Right, is that an easy integration problem to do? It is, and let's just go through that. All right, I'm kind of, I realize I probably should have done it on the whiteboard, but I think I could do this over here. So I'm going to take this, I'm going to go over here. I'm going to put it right over here now. So what do you get? Sine fourth x times cosine x over 5. And then, I'm doing this, and it might seem strange to you, but I'll do it one term at a time. It's minus 1/5 of u. And then you can get plus 1/5. That's going to be u cubed over 3. Now, if you put a 3 in the bottom, that becomes 15 then. All right? Plus c. I need to go back to x's. Let me do that now. It's going to be sine 4 times cosine x over 5 minus 1/5. What's u? It's actually cosine plus 1/15 cosine to the 15th power of u plus c. Let's look at the final answer, see how we did. Got that part. I made a mistake somewhere. Oh, I'm sorry. I see the mistake now. I gotta erase it. It's a mistake, but I think I had 15 in my brain, and that's not good. It's a cube, and that's an x over here. Sorry about that. If it's multiple choice, you probably catch that. If it wasn't, the teacher said, "Where the hell did that come from?" But anyway, let's take a look at it. Plus, 1/15. I got that there. Minus cosine x over 5. I got this over here. Plus c. We're good to the next question. Thank you.